Well, hello everybody. My colleague Bill in the previous two sessions has spent some time talking about the electrical risks associated with the workplace and the potentially catastrophic and fatal consequences that can arise from them if they are not correctly managed. In this session, I'd like to talk about the methodology the IET used to come up with an arrangement to perhaps manage those risks and hopefully reduce them in the workplace. So this session is all about the genesis of the code and how it was developed. In this session, we're going to cover how and why the code was produced, the lessons that were learned primarily from Unilever, who were the driving force behind this, the Unilever case study, what's the purpose of the code, who should use it, and where is the code applicable, how it's structured, how it's put together, what the bricks are that get it together, and when should the code be used. So that's what we're going to hopefully cover in this session. The IET, looking at this issue a few years ago now, started to have a look around and inevitably found out there was a whole plethora of material out there, complicated and sometimes contradictory, which was trying to do this sort of role, but there was certainly a gap in terms of something that could be readily usable for anybody wanting to look at electrical safety management. A gentleman called Malcolm Starstead was the chair of the technical committee, and they were really the driving force behind getting these things going. An engine room or a work group was created with Malcolm Starstead from Unilever as the leader. Paul Bashera from the IET was also on it. My colleague, who you've already met, Bill Bates, who was then working for the HSE, was with them as well. And another colleague of mine, a guy called Terry Keenan, who at the time was working for a company called Prescient Associates Limited. They started to get together. They started to evolve this document. They realized pretty soon they were actually starting to write a book, and that's not necessarily what they wanted to do. What they first of all decided was they would use the Unilever self-assessment technique or approach to allow this to work. And they developed and refined the self-assessment approach and produced the document which hopefully you've all seen, which is the IET Code of Practice for Electrical Safety Management. And there it is, there's a picture of it on the slide there. What did they set out to do? Well, they began to realize very, very quickly that writing a book wasn't necessarily what they wanted to do. It didn't want to be a textbook, it wanted to be something that can be used and put into practice in the workplace. They didn't want to write a book. They didn't want to rewrite or copy existing material. They decided we needed something new, something fresh, something which could be readily used and new. They wanted it to be of international use, and thankfully that's actually coming into practice. It is being used internationally. So therefore, there will be no reference in the document to UK legislation or standards. It's international. They wanted to get away from the elitism concept of best practice. So as you go through the document, we talk about a good practice and not best practice as we go through. It was written deliberately so that engineers and non-engineers can make use of it. It's not a deeply technical document. And it was able to produce this output, which is the self-assessment, which can be readily viewed and seen and evaluated to allow an output from the process to be published and shared if required. There is some technical guidance in there. There is some explanation and a glossary of terms which helps explain the principles of electrical safety management. So that's inside there as well. So start at the beginning, the Unilever case study. Malcolm Starstead, as I said before, was the chair of the technical committee. He also was the Unilever Group Process Safety Manager, so that was his role. The IET Health and Safety Policy Panel, he chaired that as well. and previously he had been at Unilever on their global lead electrical engineering group. He also worked for ABB, and prior to that, if you can remember that far back, ICI, where he was a senior electrical engineer. So he was one of the driving forces of the documents from Unilever. A little bit about Unilever, I'm sure most people have heard of that name. It's one of the world's leading suppliers of fast-moving consumer goods, and there are some of the brands you can see at the bottom there, which I'm sure you've all seen. The products are sold in over 190 countries, and they reckon they're used by something like 2 billion customers every day. And they have approximately 256 manufacturing sites in 69 countries. So this is a big organization, as I'm sure you can appreciate. The safety management hierarchy in Unilever was there was a company framework, safety standards that required that all locations, no matter where they are throughout the world, comply with Unilever standards. So that's, in this case, particular electrical safety standards. They comply with local legislation, wherever that might be, and local industry codes of practice as well, particularly important in the States, where they have the local codes of practice which need to be complied with almost on a state-by-state basis. What were the key safety hazards in Unilever? Well, as I think you can see from the picture, travelling vehicles is an issue. If you've ever been to sort of the Far East or somewhere like that, you'll perhaps realise that's not an uncommon cause of danger and accidents. Travelling vehicles, people falling from heights, working on unsafe platforms. Electricity has a part to play, and clearly that can be associated with electrically driven machinery. So moving machinery, people can get caught in that and cause themselves harm. If we look at where the problems and risks exist, this pie chart here will give you a bit of an indication of where it all goes. So you can see there a fairly big chunk is socket-fed equipment, people using portable appliances and getting injured or burnt or whatever from it. Inadequate installation is a big one as well, where the equipment has been installed not to a standard which I think we would find acceptable in the UK. And you can see a few other things there, work on or near live conductors. Not huge, but people come into contact with live conductors can be an issue. Unauthorised access, another one there, where people have been able to defeat or the locking arrangements simply didn't exist. So there are some of the issues which Unilever faced in terms of looking at electrical accidents. They developed this concept of self-assessment, and the idea there is it's a tool to assist sites to improve their electrical performance and achieve some degree of consistency. What we're after is people who can identify gaps in their operating arrangements and formulate improvement plans. The whole idea of self-assessment is, of course, continuous improvement, where the process can be repeated over a few years perhaps, or an annual basis, and look at how things have changed, hopefully for the better, and see where improvements or resources are required to move them up the table, if you like, in terms of performance. It's about this sort of virtuous circle here of what the assessment's all about, starting anywhere really in the circle there. If we look at the top, it's equipment. What equipment is in use? Does it conform to the local standards? And if it does conform to the local standards when it was installed, has it been maintained? And what's equally important, has it been documented when it's been maintained? Has it been done properly? That leads you on to the local procedures. What are the local procedures for carrying out those sort of functions in that particular location? What's the equipment condition? What are the risks and capabilities of people associated with it? And of course, that gets us on to the people aspects How are the people appointed to the tasks that they're carrying out? What training did they receive? Which of course leads us round the circle again to looking at how they might use this equipment on site. The self-assessment tool that Unilever came up with, they had 30 questions which people were asked to answer. The first one was all about equipment. All the workers in a location, are they aware of the dangers that can arise from electricity and electrical machinery? You would score yourself a number between 0 and 5, depending on the answer that you give. In this particular case, you would score a 0 if the training records are not available. So we've got no records of people having trained to be able to appreciate electrical hazards. You would score yourself a 1 or a 2 if there were some training records there, but it's not complete, and some refresher training is overdue or not been completed. That would get you into the 1 or a 2 ballpark. If we get to the next one, up to 3 or 4, what we're saying here, there is evidence of ongoing training, and training records are generally complete. So we're getting a lot better there. We're sort of into the 3 or the 4 range. You would score a 5 if training needs are regularly reviewed and it is documented effectively and continuously. So you'd get yourself a score there between 0 and 5, depending on how you answer that particular question. In this case, there were 30 questions to go through. I'm not going to go through all 30 of them, I can assure you. But we'll look at one more here, and this is all about portable appliance testing, socket-fed equipment. The risks associated with plug and socket fed equipment. You would score yourself a 0 if the socket fed equipment is not routinely inspected. In other words, there's no portable appliance testing regime in place. You would score yourself between a 1 and a 2 if socket fed equipment is inspected, but it's not consistent and a number of items have been perhaps missed out or not inspected at all. You would score yourself 3 or 4 if inspection work is generally complete, but there are 1 or 2 exceptions. You would score yourself a 5 if you've got absolute perfection, if you like, that the inspection regime is continuous, it's documented, there are no exceptions, and the due date for the next inspection is put onto the equipment. So that's what we've got it absolutely correct. So we would go through all of these 30 different questions and get yourself a score. What that enables you to do is to produce this sort of spider diagram. So on the spider diagram, we're going out from the center, which is 0, and the various points around the outside are the sections where the questions have been asked, and we produce this spider arrangement there. And you can see there from the different colors, we can get different results, as you would expect, for the different areas. The blue line, or web if you like, is current performance, and you can see in this particular case that is quite good in terms of overall performance, not doing too bad at all. The thing that Unilever found right from the outset was there is absolutely no need to go for a full 5 in every case, and that would become more apparent as we go through the document later on. A 5 isn't necessary everywhere. So you might decide that in this particular case, a 4 or something like that is what you perhaps might be aiming for. Clearly, not everybody will achieve this degree of performance, and you can see in the middle there, the poorest performer in there has got the very small section, and you can clearly see there's a 0 there in audits, so people are not carrying out that sort of thing. What this, I think, very easily gives you is the ability to aim for a target. That poor performer there, you'd want them to get up to at least the target performance in some agreed time period, and maybe improve even more. So that's the idea. Fairly simple, that we have these from the results of the questionnaire, from the questions, we get scores. The scores enables you to produce the spider diagram, and the spider diagram will then allow you to set targets for improvements in performance. What did Unilever find out? Well, they found out that there was, in their view, an effective process for improvement, and it did raise awareness and the understanding of the concept of electrical safety and the risks associated with it. In the early years, there are clearly some what we call calibration issues. Perhaps people have had some experience working in different parts of the world of experiences. I certainly have, particularly in parts of the Far East. To score in an arrangement like this, less than perfection would be deemed to perhaps have lost face of the management team, and people in that part of the world really do not like to lose face. So you might find that we got very high scores in some places, and clearly where you've got very high scoring locations, something's not right, and that needs addressing. The way they got round it was to use regional workshops where they brought people together, and perhaps it was less of an issue to admit that they weren't absolutely perfect at everything, and the numbers could be rationalised and made more realistic. Even after that, on occasions, there were some reality checks which were needed to be carried out by local management. They would come in and review the numbers to take an objective view on what really should be scoring. So the methodology worked. It became an effective tool for managing the assessment of electrical safety, but of course, as I said before, to become fully robust, it requires follow-up and repetition to look for this concept of continuous improvement. What did the IET decide to do? Well, they decided that this concept of self-assessment was an effective tool and decided to adopt it. As I said before, they made it usable for non-electrical engineers, so if you read it through, it's non-technical. They decided there were 4 key areas that needed the questions grouping, and you'll see that as we look at the building blocks for the document. They are inevitably the highest level first, policy. What are your policy aspects? How have you evolved your policy at the highest level? How does that work in practice? That tracks you on to procedures. So you've got the policy at the highest level that says this is what we're going to do, and then we get down to the procedural level which says this is how we put this in practice at our particular location. That leads you on to people issues. What are the people issues? Are there training issues? What about appointments, qualifications, and so on? How are people managed, and how are they effectively controlled, and how are they looking at the risks associated with their task, their particular task, and managing them? There's a section on specifics which is not perhaps relevant to everybody. You perhaps might not have any overhead power lines on your premises, so that would not be specifically relevant to you, as an example. So there's a section there on specific issues which we've grouped together. And as I say, not everybody would need to complete that because it might not be relevant to your particular location, and clearly you wouldn't have that point on your spider diagram. As we go through them, you'll see that all of the questions are asked in a similar and consistent manner. That will become very, very, very clear as we go through. They're all the same format, the questions. As you might perhaps have appreciated, the 0 to 5 scoring range that Unilever went for can create problems in itself, because if you're not careful, you have a great debate about whether it's a 3 or a 4. And that perhaps detracts from what you're trying to achieve and is not particularly constructive. The scoring system which the IET code uses is very simple. It's either 1, 2 or 3. And again, as we go through, you'll see that. So we've simplified that. It's a scoring arrangement between 1 and 3. The IET document provides a section called Technical Requirements, which might give you not in-depth explanations of some of the technical issues, but could be, I think, understood by somebody with a little bit of technical knowledge and able to interpret it. It provides advice on the reporting format, how you want to produce the output, how that might be put together in some sort of a management report or a document fed to others who have not been involved in the process. So that's the way that the code of practice works, and that's the way it was put together. These are the building blocks, if you like, of the code of practice, and I think you can see in the centre there we've got the people, we've got the specifics, we've got the policy, and we've got procedures. So they're the 4 sections in there. There's an introductory bit at the beginning. Why do we need this code of practice? And there's a sort of evaluation section at the end, which will bring it together to allow us to calculate what needs to be done to take it forward. And it sort of builds together like this. There's our 4 sections which we're going to deal with for the rest of the course over the next day or so. The people, the procedures, policy and specifics. And they're the 4 sections which we're going to look at. So here is the document. Its purpose in life is to evaluate individuals and their organisations, as you can see, to have a sufficient level of knowledge and understanding to manage the risks associated with an electrical system, regardless really of how big or small that electrical system might be. Who should use the code of practice? Well, there's a list of people perhaps who might want to think about using it. Those responsible for ensuring an appropriate electrical safety policy and procedures exist. I've been involved myself a little bit in writing these, and it varies from organisation to organisation, but there'll be somebody somewhere, or 2 or 3 people who have that responsibility and need to evaluate how effective their current arrangements are and what arrangements perhaps might need to be altered or improved. These people need to be responsible for ensuring that procedures are implemented. In other words, you need really somebody who's got the clout to make it work. So it's all very well having these procedures written somewhere in a file on a shelf that never get used. So we need somebody who's got the clout and responsibility to ensure that these procedures are implemented and put into practice. It will need somebody who's got responsibility for managing specific electrical tasks. And again, depending on your particular organisation, your company or function, whatever it is. So somebody who's responsible for managing the electrical risks. The risks, of course, vary from socket-fed equipment to major power supplies at extremely high voltages. So that depends on your organisation. This person will also be required to ensure the safe condition of equipment and machinery. And I think in the earlier sessions before, my colleague Bill gave you a couple of examples of conditions where that clearly has not been the case, and equipment has been allowed to deteriorate. The major issue, of course, at the end is about leadership. I suggest you probably need a champion in making this work, depending on what level of person that would be in your organisation. It's somebody who can exercise leadership on electrical safety, who's got the clout to make things work, and has got the authority to ensure that the recommendations, implementations are actually carried out. Just reading through the document, as perhaps some of you may have done, hopefully, I think, and I don't think I'm alone, that just reading through it will benefit individuals who want to improve their knowledge of electrical safety. So if you haven't perhaps got an electrical background, just reading through the document will give you some guidance on electrical safety issues, and perhaps hopefully sort of broaden your horizon in terms of things that you might want to be looking for and the issues associated with electrical safety. So, people who should use the code of practice, these sort of people here. Where is the code applicable? Well, I think it's fairly obvious that it's applicable in the industrial environment. So if you're a manufacturing organisation, any kind of industrial organisation generally uses electricity in fairly large quantities, depending on the size, of course. So any industrial environment would be applicable. Clearly, that would also be relevant for a commercial organisation, whether that be retail or offices or property management or whatever. So any sort of commercial organisation would find this of use as well. Utilities would find it useful, I think, depending on what kind of organisation you are, whether you're somebody who's involved in excavation work or installing supplies of various forms into properties, then the utility world would make use of it. And of course, last but by no means least, the public sector. Local governments would operate perhaps all of the above that I've spoken of, and they would be, I think, find this useful in them. So the answer to where is the code applicable, it's fairly universal. As I said before earlier on, it's not specific to the UK, so any of these ranges of activities anywhere really might make use of the document. So there we have it there. There is the code with the underlying concepts. The 4 sections, I'll repeat it just to sort of hammer it home, what we're going to talk about over the next day or so: policy, procedures, people, and specific issues. So they're the 4 that we're going to look at as we go through the next day. And there we are, we're sort of really repeating it there. There's the 4 sections, and you can see the other bits that fit in as well, the introduction and the general comments on electrical safety. There's the appendix and glossaries, and the section 8, which we'll deal with, which is how we take it forward, having gone through the document, and how we move forward to improve our performance. Thank you very much. That's the end of this particular session.